Welcome to our series of videos focusing on interdisciplinary socio-environmental team synthesis. I'm Margaret Palmer, professor at the University of Maryland and director of SOCINC, the National Socio-Environmental Synthesis Center. These videos were designed as a tool to help understand and hopefully solve socio-environmental problems. After all, environmental problems are, by definition, social problems. The first video in the three-part series presents examples of how researchers use a socio-environmental lens to study environmental problems. In it, we introduce the concepts of socio-environmental systems as dynamical systems characterized by feedback loops within and between social and ecological subsystems. We also provide several examples of socio-environmental synthesis research. As you'll see shortly, the second video provides an overview of the synthesis research process, as well as the concepts and approaches used by synthesis teams. The third video in the series presents common approaches and methods that are used to manage and analyze the diverse data needed for socio-environmental synthesis.
In this video, we discuss the approach and process used by teams of synthesis researchers. Throughout this video, we present research and experience about approaches that have been shown to foster and support collaborative, interdisciplinary team processes. Tackling complex socio-environmental problems requires very diverse teams, composed of both social and natural science scholars, often working with stakeholders or participants from other sectors. Members of these interdisciplinary teams work together to integrate data, theories, and other forms of knowledge to address difficult questions. To begin this second video, we open with a few scholars discussing synthesis as a research approach and process, and highlight why it is useful and fitting for solving socio-environmental problems. First, Dr. John Parker explains how the synthesis process can lead to new types of knowledge and understanding.
Sure. Synthesis means bringing divergent forms of information, knowledge, data together in ways and combining them in ways that lead to emergent knowledge that you couldn't predict from the parts. So the whole is greater than the sum of the parts. And the idea is that today we have a lot of pressing social and environmental problems that can only really be solved by bringing together diverse groups of experts to work together to synthesize and catalyze their knowledge in new ways.
Diverse individuals bringing many sources of knowledge can provide the raw material or data for synthesis research.
So data synthesis is really about integration of information and ideas, and that can come in many different forms. It can be the databases with numbers that often come to mind, but it can also be theories and models. It can also be written texts that people can extract for specific information or mine for patterns. And when you have a team that comes together to address a particular research problem, you may have individuals who bring very different kinds of data to the table, and that reflects their different disciplines and their differing perspectives and how they conceptualize the problem and the solutions.
Synthesis has its challenges, but many of the hurdles recognized early on are becoming less problematic. First, the culture of science is changing rapidly around the issue of data sharing and integration. In the ecological sciences, the creation of the first NSF-funded synthesis center, NCES, led to a dramatic increase in teamwork around shared data and sparked great interest in synthesis as a research method. Soon, two other synthesis centers were spawned by the NSF. Nescent supported the evolutionary research community, and Nimbus supported mathematical biology. Some of the bigger challenges today are associated with interdisciplinary synthesis. That includes a broad array of environmental scientists, social scientists, and even non-scientists. This is the type of synthesis research being done at SOCINC, the National Socio-Environmental Synthesis Center. And for this type of research, it is essential that a diverse group of participants be part of a synthesis team, and that they work together from the start, so that defining the problem and its various dimensions becomes part of a group creative process.
Co-creation is an important part of synthesis, and it's important to understand that synthesis can be done by one person who pulls together all the bits and pieces that have been done by a number of other people. But synthesis can also be done, and more commonly is being done, by teams working together. And helping a team to co-create together is really quite an interesting and difficult process. Because one of the things you're trying to do is you're trying to capture diversity. There's no point having everybody who thinks the same. What you really want to do is to have a broad group of people with a broad range of perspectives on the topic of interest, and you want to be bringing that together in a way that makes the whole greater than the sum of the parts, and that allows you to think innovatively.
The range of perspectives and expertise within a synthesis team depends, of course, on the question. The broader the range, the more challenging the synthesis process, but perhaps also more stimulating. Synthesis teams with participants from fields with distinct epistemologies, for example, anthropology, environmental science, and history, are more likely to conceptualize the problem in diverse ways than a team with all natural scientists. But there are lessons that can be learned that cut across all types of groups. Dr. Jennifer Bulk has just launched a new synthesis center at the University of Colorado at Boulder and comments on some of these lessons.
Yeah, I think the role for joining multiple disciplines and connecting them, there's certainly lessons to be learned that cross, but there's definitely nuances when you're trying to bring a group of natural scientists and social scientists into the room. And I think key is, first of all, understanding the language that each group is talking. And being able to understand how different methodologies or different approaches translate, and then how one or the other can either adopt or evolve with those. There are probably certain things about natural and social scientists getting together, but I think some of the lessons learned transcend that dichotomy. Yeah, I think one of the key challenges is cultivating and fostering diversity of perspectives. And that in doing synthesis, it really does take an open mind and a flexible approach to try and pull together different ideas, which may be coming from entirely different disciplines or maybe even entirely different perspectives. And so that, I think, is one of the keys to successful synthesis, but also requires creating a safe space for generating and accelerating insights.
Scholars like Ed Hackett, Stephanie Hampton, Dan Stokels, and others have studied the circumstances under which research teams work effectively. Certain environmental and cultural conditions are believed to promote innovative synthesis, especially those involving team members with diverse knowledge bases and distinct skills. Synthesis centers are ideal for this. Researchers are away from their home institutions, removed from distractions, and isolated with team members in a neutral location. Trust among team members is essential, as is respect for different perspectives and epistemologies. Comfortable settings, including computational support, also accelerate the process of synthesis. The science of team science is a relatively new field, but it builds on research from many scholarly fields, including organizational science and social and cognitive psychology. Ongoing research on team science is providing insights into the dynamics and effectiveness of scientific research by interdisciplinary teams. Steve Fiore, who is a leader in the emerging field of team science, has emphasized, "We know a lot about teamwork and collaborations in general, but not a lot about team science."
We know a lot about teamwork in different disciplines. So we know about teamwork in the military, we know about teamwork in organizations, we know about teamwork in aviation, but we don't know a lot about teamwork in science. What we're seeing is, although there's some similarity, there's still some differences. So in team science, the emphasis is on knowledge-intensive teams. These are people who have years and years of experience behind them. They're brought together to solve complex problems. And another important element is this idea that the performance periods are extended over long periods of time. In scientific collaboration, the dynamics unfold over time and space, over longer periods of times. And most challenging is this idea is that you're trying to solve ambiguous problems. It's not a routine type of problem that you're trying to solve. You're literally operating in an unknown problem space, and that is the beauty and the challenge of scientific collaboration. How do smart people come together and try and resolve these ambiguities?
Research by people like Steve Fiore is providing new insights. For example, Yuna Lee and her colleagues at the Georgia Institute of Technology completed a quantitative study of the relationship between team member diversity and research outcomes. They showed that increasing team size, at least up to some point, leads to more novel research. However, this is because larger teams tend to have more disciplinary or task diversity among the members. Controlling for disciplinary or task diversity, the size effect on novelty is insignificant. Research impact, as measured by citation rate, is also related to team size, but most of this is due to the diversity effect on novelty. Diversity enhances novelty, which is associated with increased citation rates. Once the effect of novelty is controlled for, team size does have an independent effect on impact due to a variety of factors, such as the network of professional connections those larger teams have. Research by Dan van Nippenburg and Julia Mel emphasizes that the synergy that is possible from knowledge diversity in a team must be accompanied by a team process, in which they exchange, discuss, and integrate this information as well as their own perceptions of the team process itself. The willingness of team members to do this process moderates the diversity-novelty relationship. But there are many contingencies of the team diversity effects, and this is a major area of research. Things like demographic diversity, personalities, and leadership attributes can moderate the effects of team diversity on performance. Similarly, team cognition, or the extent to which there is a shared mental model among team members, can moderate the diversity-performance relationship. Finally, work by D'Souza and his colleagues at the University of Missouri reminds us that creative outcomes are not just one-off giant step events, known as the aha movement. Rather, creative outcomes often come from the contribution of smaller creative events, which typically ebb and flow over time as teams work. These events can include proposing novel and original ideas that are accepted by the team, asking provocative questions that trigger more ideas, encouraging and moving to another's ideas, bringing a different viewpoint and insight into an existing discussion, making small lateral connections from one idea to another, making small tangential leaps toward a completely different idea, reweaving a past idea into the current discussion. All of these elements advance a team's synthesis progress, potentially in innovative directions. Researcher Gabriel Bammer summarizes the creative benefits of interdisciplinary team synthesis.
So the conceptual map's useful for helping you capture diversity, but it's also helpful for helping you think about how to parameterize the problem. What sort of data are you going to need? What sorts of connections are going to be important? What sorts of interactions? How's the system going to work? And that's a never-ending process, as you know. So partly what you've got to use is the knowledge that's at the table to think about the richness of the problem, but you've also got to use that knowledge to set the boundaries around the problem and to think about what's the most useful thing that this group can do to drive forward to solving or at least addressing the problem in a productive way. So one of the challenges that we have when we're dealing with the kind of problems that we're thinking about is what should be in and what should be out, where to set the boundaries. And the advantage of having a diverse group at the table is that they can help you think about what all the drivers are for this, and it can help you think about where those boundaries should be set. So what you're trying to do is to develop as rich a picture as possible that's still workable. And it's capturing all those perspectives that are at the table, it's capturing the knowledge that's at the table, it's capturing the understanding of the problem and what the drivers are and what the consequences might be and how you get to something actionable. That's the critical thing that's going to allow you to do something productive and new on the problem.
For example, questions about how to conserve biodiversity while producing sufficient food for people have long been recognized. But most of the research has focused on aspects of agricultural practices. Work by Hannah Whitman and her synthesis team colleagues took a different approach. Viewing food-insecure regions through a socio-environmental systems lens, they integrated multiple perspectives into a shared framework to capture the complexity and uncertainty that characterize these systems. Many of these cross-disciplinary problems require knowledge that spans temporal or spatial scales. For example, the primary drivers of local food insecurity and biodiversity loss may be large-scale institutional factors, not landscape or household-scale factors. Regional markets' demands or foreign investments may impact land prices and so limit land availability to local farmers. As a result, local farmers turn to the forest to hunt and forage for food. Thus, the primary drivers of local food insecurity and biodiversity loss may be large-scale institutional factors, not regional or household-scale factors. This example illustrates how different disciplinary traditions not only bring new ideas to the table, but also a focus on different scales of inquiry.
One of the great benefits of doing the synthesis method is that when you have multiple people pooling data together, you can greatly increase the extent and the amount of data that you have. And if you have a team working on a problem, you might, by pooling this data, you might be able to increase your focus from a local to a regional or global scale and look for similarities and differences across those scales. You might also be able to look at patterns and processes that occur over time.
We've described the value of synthesis in terms of sharing knowledge and integrating diverse views to yield new insights and address difficult questions. Research on what fosters team research in general and the synthesis process in particular is a young field, but it is growing. In addition to identifying how to foster the synthesis, it is also important to emphasize how stimulating and fun the process can be. Ben Halpern, who launched his career doing synthesis research and continues in that discipline now as director of the National Center for Ecological Analysis and Synthesis, talks about his perspective on the field.
So I was with some friends at a conference. It was on coral reefs and sort of the dismal state of coral reefs around the world. And we realized in order to figure out where these places were, being good scientists, we needed to basically map it and pull together all the data to figure out where the pristine places were. And to figure that out, we realized we needed to actually map where humans were having an impact, and where they weren't having an impact would be the pristine places, or at least potentially the pristine places. Got a working group funded and ended up pulling together tons and tons of data and developing some new synthesis methods for how to pull those data together to then map the cumulative impact of human activities on the oceans around the world. And you get this big map, and those last few little blue spots that aren't being impacted too much are where those pristine places were. That's kind of a classic example in my work of, like, you know, and a fun one, like, oh, here's the idea. Okay, well, how do we get at it? And really the only way to get at it is through synthesis science.
Socio-environmental systems require a diversity of information and expertise to characterize and understand. As scientists tackle research focused on these systems, they have developed and adapted approaches to interdisciplinary team science that support and encourage synthesis research. The synthesis research process begins by bringing together a team of individuals with diverse knowledge, experience, and expertise about a particular socio-environmental topic or system. Team members must be open-minded and willing to learn from one another, and a successful synthesis process often starts with communication about the boundaries of the system or the processes being studied. These conversations can lead to the development of a shared conceptual model, which helps the team move forward in asking questions and identifying data that can be meaningfully integrated. The synthesis research process can be challenging, and there is an active field of research focused on the science of team science, which provides insights into the challenges and opportunities for fostering successful synthesis teams. We began this 3-part video series with a discussion of socio-environmental systems as complex adaptive systems in which feedbacks play critical roles. we emphasized that socio-environmental systems are complex adaptive systems comprised of many distinct but interacting components. This makes interdisciplinary team synthesis a valuable approach for studying these systems. This video, the second in this series, focused on describing the team synthesis approach and its benefits. The integration of diverse perspectives and knowledge is essential to understanding and solving many of today's pressing environmental problems. Synthesis research teams are working together in innovative ways to bring together information and data to answer complex socio-environmental systems.
The next video, the third and final in this series, focuses more on the synthesis process. In it, we'll illustrate the critical first step, which is the development of a shared conceptual model of the problem or question that's being addressed through synthesis. As part of this, it's important for the team to reach agreement on the key components and drivers of change in the socio-environmental system they are studying. Finally, in the next video, we discuss essential steps in identifying the sources and types of data needed for the synthesis, as well as the tools and methods for integrating and analyzing what is usually very diverse types of data.
Mm-hmm.